Good morning, sir. Today we, Sanidhya Rawat and Tushar Prakash, are presenting our project on temperature predictions using PIC microcontroller and deep learning. So the abstract of our project is that we are simulating and then implementing the hardware of our project, in which we are monitoring temperature and predicting it in an IoT-based system using PIC 16F877A at Mega 328P, which is Arduino Uno, ESP8266, which is a Wi-Fi module, and LM35, the temperature sensor. So let's start off with the first hardware, PIC 16F877A. So basically, PIC is a family of microcontrollers made by Microchip Technology. The one we are using, the PIC 16, is a part of the mid-range PIC series. It has 256 bytes of EEPROM data and has two comparators as well as 8 channels of 10-bit analog to digital converters. Also, it has a synchronous port that can be configured as either an SPI interface or as an I2C circuit. Also, it has a 14-bit code memory and has an 8-level deep call stack. So the next part of our project is the IoT. So we are using Internet of Things to gather the data and store it on a remote server, so that we can access it through any machine. In our project, it is not clearly visible, but on a larger scale project, such a system is very helpful to access data from any point to from A to B very easily. So the next two sensors and modules are LM35 and ESP8266. So the LM35 is a temperature sensor that gives an analog signal as an output, which can be easily converted to temperature values in Celsius using a simple mathematical equation. The ESP8266 Wi-Fi module is an SoC that is integrated with the TCP/IP protocol, which allows any microcontroller to connect to any of the Wi-Fi network it has in its coverage. Then it allows us to transfer the data through the Wi-Fi. So we'll be showing you the simulation. It is this is a screenshot of the simulation, and so here's the simulation, and this part here is the LM35, and we since we cannot show it in simulation how it measures the temperature values, so we are just giving it random values, and it can be incremented or decremented. The effect is seen in the LCD. Now over to Tushar.
Yeah, so now we will show you our hardware implementation for this project. We are using Arduino Uno in the place of PIC microprocessor, cause a PIC microprocessor will be required a universal programmer, which we don't have, so we have go with Arduino Uno. Yeah, so this is our hardware implementation of our project. You can see this is LM35 temperature sensor, and this is Arduino Uno, and we are using ESP8266 Wi-Fi module. This temperature sensor is sensing the surrounding temperature and send it to Arduino Uno, and with the help of this Wi-Fi module we get the readings from this Arduino Uno to our cloud, where we store all the temperature reading to make the data set for the AI model. Yeah, so with the help of our implemented hardware, we have collected the temperature reading from April 15 to April 18. We have used the temperature reading from April 15 to April 17 for the training purposes of our artificial intelligence model, and the rest for the testing purposes. Next slide. Yeah, so in this project we have used recurrent neural network. Basically, recurrent neural network is a part of artificial intelligence, which just like focus on the pattern of previous value and predict the future value. So in this project we have mainly used LSTM, which is a part of recurrent neural network. The main thing about the LSTM is that it will also learn like which value is more important in the previous data set, and can easily discard the redundant and not so important data from our previous readings, and then increase the model performance by a lot. Yeah, so this is a simple LSTM architecture. It has like three LSTM layers stacked parallelly, and then a fully connected dense layer with a single neuron. We have trained our model for 10 epochs with the best size of 64. Yeah, so these are the results that we have got from our trained model. You can see the data points in the blue is the data which we have used to train our model, and the green one is the prediction which we are getting from our trained model, and the orange one is the actual value for that time interval. So you can see the difference between green and the orange data points are not too far, like they are pretty close. So we can say the model is trained very well, and the mean absolute error is also like 5.2%, which is like quite low. And so next, yeah, so this is the code that we have developed to train our artificial intelligence model to predict the future value of the temperature. Here we are loading the collected temperature value from our implemented hardware. So you could see we are also doing some data pre-processing, and this is the temperature value plot, and we are doing some value standardization, and then splitting the data set into train and test. This is the architecture of our model. We are in this cell we are training our model for 10 epoch with the best size of 64, and now we are predicting through our trained artificial intelligence network, LSTM network. So this is the plot. You can see the blue is the training data set, and the green is the prediction that we are getting. Okay. Yeah, if we talk about the application of this project, it could be helpful in agriculture, and for the utilities company, and also for the pharmaceutical industry, where we have to maintain the specific temperature for the preparation of the medicines and all. Yeah, so thank you, sir.
So yeah, thanks, sir. Thanks a lot.